Okay, so now we're going to move on to actually graphing the sine function. Just like we would graph like a parabola or another polynomial function. We're going to graph the sine function, but in order to understand how to graph the sine function and how it works, we first need to think about, what is the input to the sine and what is the output, right? The input is an angle. The output is the ratio of sides of a triangle. So when we graph any function on our coordinate plane, the inputs are what we think of as the x-axis, and the outputs are what we think of as the y-axis. So when we think of like just our generic function like f of x, right? So if I have f of x, this is saying that x is the input, f is the output. So when I have sine of theta or sine of x or theta are the input, and sine of theta or sine of x is the output. That's going to be my y value. So that's how I plot things. Now, this is going to relate to, wait for it, the unit circle. So, remember when I said unit circle is really important? All right. So we're going to see this little demonstration real quick, how this works. This is in degrees, just to make it in degrees. This right here is our unit circle. Our unit circle means what? It is a circle centered at the origin with a radius of 1, right? But also I have another origin, so I kind of have two graphs going on here at the same time. One is a circle, and one is going to be the plotting of the points of the sine curve on a coordinate plane. So remember we said the inputs of any function are always what we think of as generically the x-axis. The outputs are the y-axis. Here's a little slider showing the inputs. So right now the angle is at 0. So what is the sine value of 0? It is 0. So the sine of 0 is 0. We know that from the unit circle, but when I graph that, that means that I'm going through the origin. So now watch what happens as I go around the circle. So now here I'm at 30 degrees, right? So this is 30 degrees on the x-axis. The y value on the graph is 1/2 because the sine of 30 degrees is 1/2. As I continue around, right, when we get to 90 degrees, the sine of 90 degrees is 1. So the height of the curve here is 1. Now as I continue around the circle, I continue to plot the y values, or the outputs of the sine function, as the angles get bigger. So I can see that, whoop, that went further than I wanted, at 180 degrees, the output, or the sine value, is back to 0. And then I continue on, and boom, that was one time around the circle. Trig functions, all trig functions, are what we call cyclic or periodic functions, and that means that they're going to repeat. So remember with the idea of co-terminal angles, well, I could keep going around the circle, and this pattern is going to keep repeating. And if I went negative around the circle, so if I went in the negative direction, then the function will keep repeating that direction as well. So this is what we call a sine wave or a sine curve. Okay, so here we can see it again. This is just showing both the negative direction, 1 revolution, and the positive direction, 1 revolution. A couple of definitions. So these are in your note packet, but I just want to go over them and talk to them because I'm going to be using these words quite a bit. So period is the distance of one complete cycle. So if I look back here, when I say one complete cycle, this shape right here that I'm trying to kind of highlight, that is one complete cycle. So I will actually highlight that. So for the sine curve, this is one cycle. Okay, for the sine curve, that also happens to coincide with one time around the unit circle. That is not true for every trig function, but this is one complete cycle because if I went further around the unit circle, then this picture or pattern would start to repeat. So that's what we mean by one complete cycle. Amplitude is half the distance of the range. So we need to make sure we understand range. Range is the set of all output values. So the amplitude is half the distance of the range. Why do I emphasize the word distance for both period and amplitude? I do that because they both have to be positive values. So since I'm calling them distances, they have to be positive values. The domain is the set of all possible input values. Okay, so if I have y equals sine of x, the domain is actually going to be all real numbers, or negative infinity to infinity, because remember the input to the sine function is an angle. And we can go around the circle as many times as we want in either direction, so there's an infinite amount of inputs. The range, well, let's look back at this picture here. What is the lowest y value? Well, it never goes below -1, and it never goes above +1. And that should also make sense because we know that sine is representing the ratio of sides of a triangle, and it's always something divided by the hypotenuse, right? And the opposite side can never be bigger than the hypotenuse. So the range, not that one, yep, is going to be -1 to 1, but it includes both of those values. The period is, or no, let me back up. Let's go to the amplitude. The amplitude, remember, is half the distance of the range. Well, what is the distance from -1 to 1? That's a distance of 2. What is half of that? That is 1. So the amplitude of y equals sine of x is 1. What is the period? The period is the distance of one complete cycle. So if I look here, what was the distance of a cycle? It started at 0 and it ended at 2 pi. So that is a distance of 2 pi. So the period for this function is 2 pi. So this is the basic information for the sine function. What we're going to be looking at today is transforming that as well, so this information can change. The domain will actually never change for sine. But everything else can change. However, for the basic sine function, you'll want to kind of know that the amplitude is 1, the period is 2 pi. Okay, now let's talk about stretches and shrinks. So I want you to think back to an algebra class, and I want you to take a minute, pause the video, and explain if I have a 3 in front of the function, what kind of stretch or shift is that applying? And if I have this x over 2, what kind of stretch or shift is that applying to the function? So pause the video, see if you can remember, unpause, when you're ready to check. Alright, so maybe you remember if we have something outside of the function, like the 3 here, but it's being multiplied, then we follow that operation. So in this case it's multiplication, so that we would say it's multiplying the y values by 3. Another way to say that is it's a vertical stretch. Here, if I have something inside of the function, then we always do the opposite of the operation. So since this looks like x divided by 2, I would actually multiply the x values by 2. So this would be a horizontal stretch. Here, again, I want you to pause the video and think about what kind of transformations are these going to apply, the +2 and the -3 from the basic function. Pause the video, describe them, unpause when you're ready to check. Alright, so hopefully we remember, again, if it's inside of the function, it's doing the opposite. So since this looks like +2, we're actually going to go to the left 2. We might call this a horizontal shift. And this is outside of the function being x cubed. So this is going to do the operation, so it's going to go down 3, and that would be called a vertical shift. Now the reason why we want to understand that is because that's going to play a role when we're transforming trig functions. We're not going to transfer them exactly the same as we have with other functions. They do work that way, but because we have some different vocabulary words, we do a few other things differently, but the main idea of how the algebra transforms the function does not change. Next thing, real quick, I just want us to look at factoring out the b here. So we just want to understand what would that look like. If I have this quantity bx minus c, if I factor out b, that becomes x minus c over b. That's just an algebra thing, but that's going to help us with what we do with trig functions. Alright, so now we're actually going to understand how do we graph any trig function. So these are the two, they're the exact same thing, just the only thing that changes is where am I putting the, what I'm calling d here. So these are the two generic forms of the sine function. This is all going to be the same for cosine, so if we understand sine, it makes cosine really easy. So we're going to refer to the a, the b, the c, and the d, because those are going to help us with figuring out our information about the trig function. So just kind of bear with me, write this stuff down for now, and then I'll explain it, it'll make more sense later. So remember we talked about amplitude. Amplitude is going to come from the a value. That's another way to think about that is it's the vertical stretch, right? So the amplitude is going to be the absolute value of a. It's absolute value because a can be negative. And if a is negative, that will be a reflection of the graph. but if you are asked what is the amplitude always has to be a positive value. The period is going to be 2 pi divided by b. So if b is 1, then the period is 2 pi. That's why for the basic y equals sine of x, the period was 2 pi. We can think of that as relating to our horizontal stretch or shrink. Again, we don't want to totally treat these like we do other algebraic functions. They do work the same, but in terms of this terminology, it kind of switches things around a little bit. So intervals. Intervals are just going to be a key component when graphing, and this is going to be the period divided by 4. So we're going to find the period, and then we're going to use the period to find the intervals, and that's going to help us graph. The vertical shift is just going to be the d value. So if d is here, or if it's here, if it's positive, we're going to go up that number. If it's negative, we're going to go down that number. And then the horizontal shift is going to be c over b. And there's 2 ways we can come up with that. One of them is factoring out the b value. So if I have b, then this is x minus c over b. Or the other option is I can set the bx minus c equal to 0, and then I can solve for x. So that's also how I can get c over b. Now, one thing I would point out, if I do this technique, then this is going to be the direction of the horizontal shift. If I just factor out the b, and then I have to keep in mind that it's going to be the opposite of whatever this sign is. So if this was like minus 5, then I would actually go to the right 5. If it was plus 5, I would go to the left 5. We'll again see some examples of this. So now let's just talk about some strategies real quick. So our strategies, we're going to first find this information. So if we're given an equation and we want to graph, first we want to find the amplitude, the period, the horizontal shift, the vertical shift, and the intervals. Then we were going to draw our axes, and then we will label the intervals, or we will, start at horizontal shift, and then count up by intervals. So I want to emphasize the intervals are a distance. They are not necessarily a location. Sometimes they will be both, but they are always a distance. That's how we want to think of them. The horizontal shift is always going to be our starting x value. And then we also need to apply our vertical shift. And then draw the shape, and I'll explain what I mean by that when we do an example. Okay, so let's look at an example. We want to graph 2 periods of this. So first we need to identify this information. Amplitude, I see that that's going to be 3. The period is 2 pi over b. The b value here is 2. So that's 2 pi over 2. So the period is pi. The intervals, remember, are the period divided by 4. So that's pi over 4. The vertical shift, there is nothing added or subtracted outside of the parentheses or outside of the function, so that's going to be 0. And the horizontal shift, there's nothing added or subtracted inside of the parentheses, so that is also going to be 0. I'm going to stop this here because we're going to run out of time on this video, but we're going to pick up the graph with the next video.